Welcome to the video for what is an integer. Integer data are numbers without decimals and may be negative or positive. They can hold a value of plus or minus a little over 2 billion, as you can see from the top line. The green line shows us examples of valid integer data. The red line shows us examples of invalid integer data. Due to the decimal points, these are not valid. If you're looking to store a number that does not need to have a decimal, maybe the number of people in a room or the amount of cats you own in your crazy cat lady simulator, then an integer would be good to use. This is what your standard getter and setter look like for an integer variable. You're going to find that they are very, very familiar. If for some reason you have less than a whole number of cats in your simulator, then you may want to look at using a float instead. Also, leave a comment below with the name of your game so I can check it out. Welcome to the video for what is a float. Float data are numbers with decimals and may be either negative or positive. They can hold a value in scientific notation of approximately 3.4 to the power of 38 with 7 digits of decimal precision. If you're looking to store a number that uses a decimal place, like trying to divide 5 and get an accurate result of 2.5, or any other value that has a decimal, then a float is what you're looking for. As you can see from the top green line, both of those values are valid floats, as they contain either a positive or negative number and they have a decimal point. The bottom line also contains valid floats, as you can store whole numbers in a float. You will just end up with a decimal of 0.0, giving you either 10.0 or perhaps negative 56.0 as examples. Floats are commonly used to represent linear color, where each RGB value is 0 to 1, and also used in a lerp, where the float variable represents the 0 to 100% value. Floats use the standard setter and getter nodes and should be fairly common at this point. Is a simple variable that's used to determine if something is either true or false. Here you can see our standard setter and getter nodes for a bool variable, with a simple checkbox to indicate if it's true or false. A bool variable is commonly used when checking if you've collided with something, or perhaps we check to see if we have any ammo for a crazy cat lady gun, so we can fire more cats out of our cat bazooka. Welcome to the video for what is a string. A string is simply a series of alphanumeric data. For example, this is a long string is perfectly valid. 134.513 Echo Charlie $sign is perfectly valid as well. To set a string variable, you simply type in what you want to see. And now you have set the string variable to I want to see this work. An example of using a string may be debugging during the game and we want to see a success message after something has successfully run. We have set our debug string to be the word success, and when we run this in the top left, you will see it say success. Welcome to the video for a group of alphanumeric characters that have special handling functions to allow you to easily change its value to other languages in the case you are doing localization. As you can see, here are two simple examples on the screen. Localization itself is something that is beyond the scope of this. If you wish to set your text variable, simply type it into the space provided. As a simple example, what we are going to do is take the text block from the previous screen you saw and change it to give you a random name that is displayed. I have an array that contains 5 names. I am getting one of those random names and assigning it to the format text node. The format text node replaces parts of a text string with text and displays it and outputs it as needed. Here's an example. You'll notice it says hello Dennis. If we run it again, hello Eric. And again, hello Billy. The format text node is a great way to have things be changed easily by replacing data. Welcome to the video for what is a name. A name variable is primarily used to identify things. It is not case sensitive and has no real functions to manipulate any of the content like a string does. Here's our standard setter and getter nodes, and you can set the node just like a string or text by typing in the blank box. An example of what a name might be used for is to get the tag of an actor and see if it is there. So in this example, we're going to get all the actors of our class called box that's in our scene. Check the first one, see if it has a tag that we have defined down here. And if it does, change the string on our screen to found it. Now, I already have this box in our scene, and it has a tag of super box with the S and the B capitalized. I will change our name variable to look for here to super box with random capitalization, and you'll notice when I run it now, we will find the box. Names are handy and used as tags because of case insensitivity, and you'll find it on things such as actors, bones, material parameters, and asset names. Welcome to the video for what is an array. An array is simply a variable that stores a bunch of stuff. If we want to keep track of more than one thing, this is the type of variable we might want to use. So for example, instead of 10 different strings, we might use one string array. A good example, as you can see, might be the list of children in a classroom, or perhaps a scoreboard for a sports game. Here's our simple setter and getter for our arrays. When you use the setter, you'll notice that it displays the variables in a nice organized list with the ability to add and remove elements from that array. The example, I simply take our string array, which has 4 children's name, and put them on our screen. And then I take our integer array, which contains 5 integers, and put them on the screen as well, which you can see in our original example. Welcome to the video for what is a byte. A byte is a variable that can simply hold the values of 0 to 255. As you can see in the green, 10, 255, and 27 are valid, whereas negative 15 is invalid because it is negative, 64.2 is negative as it has a decimal, and 500 is invalid because it's greater than 255. We have our standard setter and getter nodes for our variables. You'll notice if we type in 240, it sets fine, but if we set up a variable value outside of our range of 0 to 255, such as 900, it will not save the value. Welcome to the video for what is a vector. Vector data is a collection of 3 float values stored in one variable. Depending on the use, this is commonly referred to as x, y, z, or RGB. If you're looking to store a 3D representation of something, then a vector is normally what you're looking for. Traditionally, a vector would be used for something such as a location or rotation, but you can also use it to store the values of a color, where X, Y, Z is the equivalent of RGB. You'll find that that is common in the material editor when working with colors. As you can see on the top green line, 100.0, 100.0, and 200.0 is a perfectly valid float, whereas 1.0, 1. Something such as storing the RGB value of white. These are our standard setter and getter node for vectors. But one nice thing is, due to a vector actually being a collection of 3 floats, you can right-click and split the struct pin, and it will turn it into 3 vector float variables. This is nice when you're trying to access an individual value, and anywhere there is a vector pin, you can split it. It can be handy, for example, if you are trying to do a line trace to find something that is approximately 100 units in front of the character. You can take your standard vector variable, split the struct pin into the X, Y, Z, add 100 to the X, and put that as your end destination for X, and simply copy over your Y and Z as is. It also lets you use your original vector variable for the start, and you now can tell what is approximately 100 units in the X direction by doing a line trace, splitting your vector.
If your computer runs like this, or seems like it's running inside the here, then just...
Welcome to the video for what is a vector 2D. Vector 2D is a collection of 2 floats stored in one variable. Depending on the use, this is commonly referred to as X and Y. If you're looking to store a 2D representation of something, then a vector 2D is normally what you're looking for. Traditionally, a vector 2D would be used for a position on an image or UI element where you have a flat picture and it doesn't contain a Z or a depth value. As you can see on the green line, 100.0 and 100.0 would be a valid vector 2D. The red line shows an invalid vector 2D as it has 3 float values, and that is 1 too many. As you can see, here is our standard setter and getter nodes for our vector 2D, and due to them being a collection of variables, you can right click on any of the vector 2D pins and split the struct pin into the 2 float variables. You'll find this is pretty handy and common when you are doing something such as adding an X or Y. Maybe you want to move something over to the right or left and you just want to add to the X. An example of using a vector 2D would be common in our user interface. Perhaps we want to get our text block and move the shadow offset over, which would be an X and a Y. Or maybe we want to get the same text block and get the position to store for later because we want to use some form of fancy effect. Welcome to the video for what is a transform. Transform variable is a collection of 3 individual variables all tightly packed into one nice package. You'll find 2 vectors, a location and a scale, and you'll also find 1 rotator. Oddly enough, is used for rotation. If you're looking to store information on where and how something is in your scene, then a transform is most likely what you would use. Traditionally, a transform would be the root of an object, such as a player, and used whenever we want to know where it is, if we've resized it, or if we've rotated it in any way. These are your typical setter and getter variables. As these are collections, you can right click and split the struct pin on any transform to get access to the base, location, rotation, and scale. And as these are vectors and rotators, you could then split them again to get access to the base floats for the X, Y, and Z. You can right click and recombine any pin that you have not made any changes to. And this is a great way to make simple changes where you only need to adjust one of the values. Examples of a transform would be common in an actor, and typically would be needed to move your actor across a scene, or perhaps you want to locate where an actor is because they are the target of your heat-seeking cat bazooka. As an example, maybe we want to move our static mesh across the scene along the x-axis. Well, we could get the world transform of our object, which is a transform, split it into our location, rotation, and scale, split the location again since we only want to adjust the x value, add 1 to our x, and then put it in our set world transform node, which takes a transform. Since we only want to mess with the x, we've already split this and split it again and simply connected our values. When we go ahead and run this blueprint, you can see our actor is moving along the x-axis on its own every tick. Welcome to the video for what is a rotator. A rotator is a collection of 3 floats stored in one variable that represent the rotation in 3D space, pitch and yaw. You'll also find that the rotator is limited to the range of 0.0 to 36.0, as this represents degrees of rotation around each axis. The green line represents a valid rotator. The red line represents an invalid rotator, as 415.0 is outside of our bounds of 0 to 360. This is our standard setter and getter for our rotator variable. The red line to 36.0, as this represents limited to the range of 0.0 to 36.0, as this represents degrees of rotation around each axis. The green line represents a valid rotator. The red line represents an invalid rotator, as 415.0 is outside of our bounds of 0 to 360. This is our standard setter and getter for our rotator variable, and as it is a collection, you can right-click and split any of the rotator struct pins and get access to the default float values: X as roll, Y as pitch, and Z as yaw. Now, rotators can be a bit tricky to get your head around unless you actually use your head to get a handle on them. When you tilt your head left or right, you're changing the roll of the rotator, where positive is tilting it right or clockwise, and negative is tilting it left or counterclockwise. If you were to look up or down, you will be changing the pitch of a rotator. Lastly, if you wanted to change the yaw, it's the same as if you rotated your head to look right, being positive, and to look left, being negative. Hopefully that helps you get a handle about rotators. Welcome to the video for what is an enum. An enum, or enumerator, is basically a list of numbers that have a label associated with them. A good use for them is when you want to keep a list of options in one place for easy selection, and it also makes it easier than having to figure out between 0, 1, and 2 that 2 is equal to guacamole. Having these values in an enum also helps to prevent errors, as you can read the value of them clearly and prevent design time mistakes. Here you can see our setter and getter, and our setter has a very nice, easy to use, convenient list. To create one of these, we will go into our content browser, right click, go to blueprints, and create a new enumeration. When we open this up, we will find that we have nothing. We click new, and we can create our first value. Any other values we wish to create, we simply hit new each time. We can reorganize our list here, or we can delete any unwanted values here. Once we are done, we hit save, and then we can use our new enumeration. In our example, I've already created one that will contain 4 values. those values will pertain to 4 different types of workers. If we run our example, we will see they get nothing. Well, why is this? Right now, our first one is simply taking our enumeration, comparing it to see if it is matching permanent, and then printing out text. Well, since our enumeration is intern and not permanent, nothing printed. Let's try this again. Now we can see we print out wage 125 and they get waffles. When we previously saw they got nothing, we were using a switch on generic enumeration. What we do on that is we take our enumeration value, plug it into our switch, we get 4 nicely labeled outputs, and then we can do what we want. Let's see what happens if we have a contract employee and we hit play. We will see contract employees get pancakes. We take our enumeration value of contract, feed it into our switch, it goes in and comes out, they get pancakes. Nice and simple.
Hello and welcome to the video for what is a struct. Well, first of all, we need to determine why we would want to use a struct. Let's say, for example, we have a simple role-playing game. I'll play my example here. And we do damage, and the orc takes damage. Well, the orc is named orc, so we have an enemy name variable, for example. And the orc has health, so we have an enemy health variable. And let's say we wanted to add more stats, like armor and mana and strength, maybe agility, maybe a weapon. All of a sudden we're going to have 10 different variables for that one enemy, all named different things, all in different places, not really organized. Well, that is what a struct is for. A struct is a way of organizing different variables into one nice organized structure. So we'll go ahead and we'll go into my generic widget items and we'll create a new struct under blueprints, structure, and we'll name this one my struct. Now, when you open it up, you will see the following page. You have the ability to set the variable name and the variable type, as well as create a new variable. So for our example, let's say we want this to be called name, and we'll set it to the type of string. Let's add a new variable. We'll name this one health, and we will set this to the type of int. And you could go ahead and you could continue on as many as you want, but for our example, this is all we're going to use. On the right, you'll see the default values, and this is where you can set any of your defaults for any item that is created inside this structure. So we'll just set it to 100, and we'll set the name to monster. We'll go ahead and save that, and we're done. Now, in our example here, I've gone ahead and already created it. I actually have a struct called monster struct that contains the values that we have just created in our example, a name and health. So to go about using it, what you're going to need to know is you need to break it apart, pull any data out of it, and then remake it with the new data, and then save it out. So for our example here, I take our enemy, and then save it out. So for our example here, I take our enemy, break it into the parts of the structure, which gives me the name and the health variables. I subtract 10 from our health, and then I put it back together with the updated health value and the original name. This gives me a new monster struct that I then reassign and set in the original enemy variable. I have an update health display here, and all this does is simply updates the health you see on the screen. So when we run this and hit play, every time I do damage, the enemy structure is updated and I remove 10 points of damage. So rather than having to go in and keep track of the enemy health and the enemy name and the enemy armor and the enemy weapon all separately, we simply have one item called enemy, which has multiple variables underneath it depending on what we want. One nice and handy feature of this is, let's say I wanted to have a game where you had 3 enemies you could attack at one time. Well, then I would have enemy 1 name, enemy 2 name, enemy 3 name, enemy 1 health, enemy 2 health, and as you can see, it would become quite cumbersome. Well, there's nothing stopping you from taking the original enemy itself. Well, actually, let's just make a new variable, make it easier, and we'll call this one new. We'll call this one enemies. And we'll go ahead and turn this into an array, and now we have an array full of structs, full of variables for our enemies. So in here, you'll notice we have different elements, and each element contains the variables, and that's it. You would work on it in a, you would take your actual enemies, and then you could break it apart by getting the correct one, and then you break that apart into your monster struct, and then there's your variables for the first one. One thing that's handy is you can actually take your enemy once you have your struct here where it shows a monster struct structure, and you can split the pins directly here instead of having to break it apart. This is nice and handy if you split the pins directly here instead of having to break it apart. This is nice and handy if you just need to pull something out and you can actually not have to use the break node. And that's it. That's a simple use for the struct. Go ahead and use it to organize a bunch of variables into a nice, happy, organized organization.
My name is Leticia Akawe. I'm 22 years old. After graduating, I
Struct. Let's say, for example, we have a simple role-playing game. I'll play my example here. And we do damage, and the orc takes damage. Well, the orc is named orc, so we have an enemy name variable, for example. And the orc has health, so we have an enemy health variable. And let's say we want to add more stats, like armor, and all of a sudden we're different things all in different places, not really organized. Well, that is what a struct is for. A struct is a way of organizing different variables into one nice organized structure. So, we'll go ahead and we'll go into my generic widget items and we'll create a new struct under blueprints, structure, and we'll name this one my struct. Now, when you open it up, you will see the following page. You have the ability to set the variable name and the variable type, as well as create a new variable. So for our example, let's say we want this to be called name, and we'll set it to the type of string. Let's add a new variable. We'll name this one health, and we will set this to the type of int. And you could go ahead and you could continue on as many as you want, but for our example, this is all we're going to use. On the right, you'll see the default values, and this is where you can set any of your defaults for any item that is created inside this structure. So we'll just set it to 100, and we'll set the name to monster. We'll go ahead and save that, and we're done. Now, in our example here, I've gone ahead and already created it. I actually have a struct called monster struct that contains the values that we have just created in our example, a name and health. So, to go about using it, what you're going to need to know is you need to break it apart, pull any data out of it, and then remake it with the new data, and then save it out. So for our example here, I take our enemy, break it into the parts of the structure, which gives me the name and the health variables. I subtract 10 from our health, and then I put it back together with the updated health value and the original name. This gives me a new monster struct that I then reassign and set in the original enemy variable. I have an update health display here, and all this does is simply updates the health you see on the screen. So when we run this and hit play, every time I do damage, the enemy structure is updated and I remove 10 points of damage. So rather than having to go in and keep track of the enemy health and the enemy name and the enemy armor and the enemy weapon all separately, we simply have one item called enemy, which has multiple variables underneath it depending on what we want. One nice and handy feature of this is, let's say I wanted to have a game where you had 3 enemies you could attack at one time. Well, then I would have enemy 1 name, enemy 2 name, enemy 3 name, enemy 1 health, enemy 2 health, and as you can see, it would become quite cumbersome. Well, there's nothing stopping you from taking the original enemy itself. Well, actually, let's just make a new variable, make it easier, and we'll call this one new, we'll call this one enemies. And we'll go ahead and turn this into an array, and now we have an array full of structs, full of variables for our enemies. So in here, you'll notice we have different elements, and each element contains the variables, and that's it. You would work on it in a, you would take your actual enemies, and then you could break it apart by getting the correct one, and then you break that apart into your monster struct, and then there's your variables for the first one. One thing that's handy is you can actually take your enemy, once you have your struct here, where it shows a monster struct structure, and you can split the pins directly here, instead of having to break it apart. This is nice and handy if you just need to pull something out, and you can actually not have to use the break node. And that's it. That's a simple use for the struct. Go ahead and use it to organize a bunch of variables into a nice, happy, organized organization.
My name is Leticia Akawe. I'm 20.
Hello and welcome to the video for What is a Struct? Part 2. So, after doing the first video, it was brought to my attention that there are some other features of struct that we should go over, so here's the video for them. I've modified our original blueprint, and I have added this other one called damage using set. As you can see, when we damage, it goes down, and when we damage using set, the same thing happens. But behind the scene, there's a small difference. So originally, we would take the enemy structure, break it, change the health, and then copy both values across back to the make monster struct, and then set our enemy back to normal. Well, there are a few small things you can do. When you are breaking apart a struct, if you view your details panel, there is a category dropdown. This will allow you to choose which items you want to see on your break. So for example, I have unchecked name because I don't want to change the name. Now, I've gone ahead and changed the health value by -10 here, and then I'm using the set members in monster struct instead of the make struct. So for this one, I've done the same thing. I've gone ahead and pulled up the default category under details. I've unchecked health, and I've got, unchecked name, and just made health checked. So now you notice that not only is it a lot cleaner, we don't have the name hooked up. Well, when you're using set members and you do not have a variable checked, because you have to pass in the original struct, it will simply copy along those variables. So imagine if your enemy had 20, 30 different variable types and all you wanted to do was change the health. Well, this makes it nice and easy. You don't have to copy across 30 different wires. You just set it up only to modify the health. Now again, after we go in ahead and set just the health, we go ahead and we set our enemy variable back, and then we update our health. That's why when we run the example, it works the same way, but in the actual blueprint itself, it's a little bit cleaner. Now, there is one issue with this. Right now, currently, set members does not work properly if you are pulling a struct out of an array. So keep that in mind. If you have an array and then you're trying to use the set members, it will not properly go back into the array if you are trying to set the element. You will have to take this output struct, make a brand new struct using the make struct, and then you can go ahead and set the element or insert the element. So that's it. This is just a quick little update, and it shows you a nice, easier way to organize your structs. Bum, 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 bum.
Tomatoes?
Hello. Well, the set variable is pretty simple. It's a variable type that basically holds things uniquely. It's kind of like an array, but the values in it are unique, and it's really quick and simple to access. It's a lot quicker than an array if you just simply need to hold a list of things that you are guaranteed to have them be unique. So let me go ahead and show you my example. I'm gonna hit play, and I have a grocery list. I want to get some bacon. Okay, cool. I want to make a hamburger, so let's go with some meat and maybe some cheese. Oh, we need some buns. And at some point, I've got a large list going, and I start losing track because someone else is telling me what I need. And I'm starting to think to myself, well, do I have that on there? Oh, we need bacon? Okay, so I'm going to add bacon. Well, you notice when I hit enter, bacon didn't get re-added. I could even technically write bacon lowercase, and it's not going to work because I'm using a name. Now, bacon 1 would get added, but bacon itself, I cannot re-add. That's because I'm using a set and I'm storing all of our variables in our set, and it simply allows me to make sure I have a nice, easy, unique list. Simple as that. So let's go and look at that. To create a new set, simply add a new variable. You can click on your drop-down list here and change it into a set. Now you notice I can't do this with a Boolean. And if I actually went to a text and I tried the same thing, I'm going to get an error when I try to compile. Only certain variable types can be changed into sets, and the ones that cannot, it will give you an error. Pretty much the main ones I ran into is going to be text and Boolean. Objects and things like that can be in a set. So in this case, I would want, for example, strings, change this to a set and hit compile, and now I have a set. So for example, I could add, and you'll notice I get an error. Well, my default value here is blank. I can't add another one. I could type in type and hit add, and again I'm going to get stuck. I type in type and I get an error. Duplicate elements are not allowed in set properties. And that is the key for sets. It's just a list of stuff. It's unordered and it's unique. That is the key of a set. Now, looking at my example, it's pretty simple. All I'm doing is whenever I hit enter, I'm adding whatever it was straight to my grocery list. If you'll notice, there's no validator here. I'm not saying, does this item already exist? I'm not using the add unique from the array. I'm just simply adding it. If it already exists, it's simply going to do nothing. We'll get a false. If it adds it, we'll get a true. Simple as that. The rest of this is just me putting it on the screen, so we can ignore that. Now down here, we'll find the 11 nodes that make up the set. And this is how we can manipulate it. First one's pretty simple. It's our length. How long is our set? Output's an integer, really simple. Then we have add, and we have add items. These are going to basically be the same, except this one takes in an array and adds the items to the set. Keep in mind, unique. So even if we add 10 things and 3 of them were already there, we're only going to end up adding 7 new ones. Add takes in the value and outputs again, was it true? Did it add it? Or false if it was already there or it couldn't add it. Contains, this is basically how we check to see if something is in our set. If you'll notice, you can't get a value out of a set, and that's because you have no reason to get a value out of a set. It's a list. I want to add bacon. Okay, well, add bacon. If it's there, you're going to get back a valid true, or false if it's there, or true if it added it. If you simply want to check, for example, I have people signing up for my list, and I put their names on there. I want to see if Bobby signed up on my list. Well, does my set contain Bobby? If so, true. If not, false. We have remove items, and clear. These ones are pretty simple. They basically remove one item, remove multiple items, or clear the entire set. If we remove an item, we'll get back true or false. False is basically going to indicate there was nothing in there that matched. True means, yes, it removed it. Remove items is the same thing, except, again, takes in an array and removes a bulk of items. Clear gets it all gone. Now, the rest of these are specific cases. We have to array. This is useful if you actually want to do something to the data. If you take your grocery list, which is a set, convert it into an array, you now get an array that you can manipulate out of those items. Our last three are, again, pretty unique. They are union, difference, and intersection. This is a way to basically input more than one set and output the results. And they all do different things. So for example, let's go with intersection. This one's pretty simple. Intersection basically takes in two of them, an A and a B, and the result will contain all elements that are in A and B. So for example, I have a list of people who went on the field trip, and I have a list of students. I want to see which ones are the same. I basically want to compare so I can see who's missing. Well, if we intersect that, who is in our class and who is on the bus, the intersect is going to give you the matching. It's basically going to give you the results of those two things that match. So we're going to cut out the people who were not on the bus. Now let's say we wanted to actually see who wasn't on the bus. That's what we have here. Difference. It assigns the result the relative difference of two sets. The result will contain all elements that are in set A, so for example, our student list, but are not found in set B. For example, who's on the bus. So we put in all of our students, we put in who's on our bus, and this gives us the difference between the two. So we're going to find out who was missing from our bus by calling the difference. Union basically assigns the results to the union of two sets. It'll contain all of the elements that are in set A, in addition to all the elements in set B. Now keep in mind, it's unique. So set A contains, for example, everyone who went to the first field trip. Set B contains everyone that went to the second field trip. The output will give me all of the students who went on both field trips as a complete list. If the same person went on A and B, it's still one entry. If someone only went on A, one entry. Someone went on B, one entry. So it adds everything together basically and spits out a unique list. So those are your three unique nodes for sets. Sets are useful, as you saw, when you basically want to have a list that contains data that is unique. That's the whole point of a set. Honestly, it's as simple as that. It allows us to, as you can see here, well, nice, they don't have a tooltip. That would have been nice. But again, it allows us to make a unique list of stuff. That's what a set is. And that's it. That's going to wrap up our set variable type. Hello, welcome to the video for what is the map variable. The map variable was introduced to Blueprints earlier than 4.15, but only for editing purposes. In 4.15, we can actually create maps in the editor, and we'll cover what they are and what they do. Maps are basically like a structure that can contain two things, and they are related and linked to each other. That's probably an easiest way of thinking about it. Maybe even like a two-dimensional array. But they are symbiotic. Basically, they are linked to each other, and you have a value and a key is how it works out. The key is unique. The value is what the key is pointing to. So let me show you basically what I mean by that. If we go over here and we'll create a new variable, and we'll call this one our new Hello, welcome to video 4. What is data table?
Don't advertise on Google Ads or Facebook.
Tomatoes.
Hello, welcome to the video 4. What is simple move to the actor and location nodes? Let's run this quick little example, and I'll cover what we're going to cover. So when I hit play, you're going to see our little red pawn comes over to our little gray pawn, which is my player here. If I was to actually replay this, and I'm going to move my character this time, you're going to see the red pawn follows my character until he gets to it. And once he gets to it, he's going to go ahead and he's going to stop. So let's see how we did this and what these two nodes are for. So to start off with, we have our simple move to location node, and we have our simple move to actor node. And they're pretty simple. They each have an execute wire to come in, they have two inputs, and then they have the execute wire out. And that's it. These are very simple nodes. You're not actually even going to find, if you type them in under simple move to, you'll find them in the navigation section, not in the AI section. However, I would consider these basic AI, as they are using the navigation mesh, and you are required to have an AI controller hooked up to your pawn in order to actually have them work. So let's see how they work. We'll start with the simple move to actor, because that one's pretty simple, as the name says, and it basically has two inputs. We have a controller and a goal. The controller is the controller that you have created that you have attached to your pawn that will allow it to move. Now, in our example here, I have created a generic AI controller that, as you can see, it has no functionality. It's empty inside. It does nothing. But because it is an AI control, it inherits from AI controller, it does have 2 extra components added on automatically. So to create one is pretty simple. We would just blueprint class, extra components added on automatically. So to create one is pretty simple. We would just blueprint class. You can go down here under all classes and expand it. You can type AI. And you're going to find under controller, you'll find the AI controller. So our AI controller, after you've done that and created it, that's all you need to do. Because we're not actually doing anything but a simple move, your generic AI controller doesn't need any extra functionality. So again, the main reason why you need an AI controller is it adds these 2 extra components, path following component and the actions component. And this allows the AI controller to take input from an external node, like the move to, and then find on the navigation where it should move to, and then move to. Simple as that. So, what I have here is my generic AI, and then move to. Simple as that. So, what I have here is my generic AI character. That's what we've been looking at so far. I have all of these controls down here, which I copied over from my generic character, but I'm going to go ahead and delete them all. These are not needed, assuming I can actually get rid of everything. These are simply leftovers from the original character that I brought in, and when you're using an AI controller, you're not going to have manual control over it, so therefore, there's no reason to keep that in there. Now, if you were going to have something, for example, where it's a AI controller when you're not physically possessing it, and then you allow your player to possess it, then you would have 2 different controllers, and you would swap in and out between the AI and the player's controller. So, right here we have get controller. The node is basically going to get the controller that's attached to this pawn, and if we look in our class defaults, and we scroll down, we're going to find our controller class for the AI is AI controller, or generic AI controller. Either one of these will work. AI controller is the default that comes built into the engine. Generic AI controller was the one I created. Now if we go and run this, you'll notice our pawn works. Now to show an example of what I meant by it needs to be an AI controller, if I switch this over to a generic player controller, or a player controller, and hit play, you'll notice the pawn doesn't move. The pawn is trying to move, but because the controller attached to it is not an AI controller, and doesn't have these components, it's not going to work properly. So make sure you have an AI controller parent for the controller that you have hooked up to your pawn that you intend to be controlled by the navigation system or the AI nodes. So there's our controller setup. The next one is, where are we going to? Now the simple move to actor takes a actor as the reference for the goal. So I'm doing this pretty simply. I'm getting the player's controller, getting the controlled pawn that the player is controlling, and feeding it in as my simple move to. So as you can see, when we run it, he's moving to that one. And that's why when we run it and we move our character, you'll notice he's trying to chase it down. And once he gets to it, he finishes. Now here's one thing that the simple controllers, the simple move tos, do that you may have an issue with, and why this is the basic form of AI. Let me go ahead and hook up my print string here. And you're going to notice immediately when I hit play, before my pawn, my AI, gets to my character, it's actually going to print out the string. See how on the top left it says moved?